determine where the graph of y equals 1 plus 1 over x is concave up or concave down, and we also wish to find the points of inflection. How we're going to do this? We're going to start by finding y double prime, and we're going to find the points where y double prime is equal to 0 or y double prime is undefined, and we're going to make a sign chart. We're going to make a sign chart with y double prime and with all the points that we determined in part 2 located in the chart, and we're going to determine where y double prime is negative and where y double prime is positive, and we're going to use this chart to make the final conclusion. So let's do just that. We're going to start by finding y double prime. Y prime in this case, y equals 1 plus 1 over x, is going to be negative 1 over x squared, because x to the negative first, if you take derivative of it, it's going to be negative 1 times x to the negative 2. Y double prime is going to be 2 over x cubed, because that's negative x to the negative second power. Negative 2 times negative 1 is 2 over x cubed. So where is this going to be 0 or undefined? Well, that's when y double prime is 0 or undefined. Can this be 0? It cannot, because the numerator of the fraction is never going to be 0. Can it be undefined? Yes, it can. That's when x cubed is 0 or when x equals to 0. Now let's make a sign chart. Y double prime, we have 0 as our value determined from step 2. To the left of 0, such as negative 1, plugging negative 1 into y double prime, we have 2 over negative 1 cubed, which is negative. Plugging 0, a value to the right of, plugging 1, a value to the right of 0 into y double prime, you get 2 over 1 cubed, which is positive. So now we know the graph is concave downward to the left of 0 and concave upward to the right of 0. So we know y is concave upward on 0 to infinity, and concave downward, not concave upward again, concave downward from negative infinity all the way to 0. Now, we also have to find the points of inflection. Points of inflection are the points on the graph, on the graph of y, where the concavity changes. In this case, you might say, well, isn't point of inflection just when x equals 0? Isn't that where point of inflection is occurring because the concavity changes? Well, yes, you are kind of right. The concavity does change at x equals to 0, but this is not a point of inflection. And the reason it is not a point of inflection is I have a graph of our function 1 plus 1 over x right down below, and as you can see, at x equals 0, the graph is undefined. The function is undefined because when you plug 0 into this function, you're dividing by 0, which is going to cause vertical asymptote because you're dividing 1 by 0. So since x equals 0 is not going to be on the graph of the function, we disregard this as a point of inflection. So in this case, there are actually no point of inflection. But nevertheless, we still have to include 0 in our sign chart for testing for concavity, because concavity can still change at 0, but we don't count it as point of inflection. Now, I have a graph of 1 plus 1 over x, as I said before, down below from Desmos.com. And as we can see, the graph is concave downward to the left of 0. It is frowny face. And the graph is concave upward. It's a happy face to the right of 0. So our predictions were true.